A junction diode which acts as a variable capacitor under changing reverse bias is known as a Varactor diode. When a p-n junction is formed, depletion layer is created in the junction area. Since there are no charge carriers within the depletion zone, the zone acts as an insulator. The p-type material with holes considered positive as majority carriers and n-type material with electrons negative charge as majority carriers act as charged plates. Thus the diode may be considered as a capacitor with N region and P region forming oppositely charged plates and with depletion zone between them acting as a dielectric. This is illustrated in Figure 1. A Varactor diode is specially constructed to have high capacitance under reverse bias. Figure 2 shows the symbol of Varactor diode. The values of capacitance of Varactor diodes are in the picofarad range. Theory: for normal operation, a Varactor diode is always reverse biased. The capacitance of Varactor diode is found as following, where CT equals total capacitance of the junction. Epsilon equals permittivity of the semiconductor material. A equals cross-sectional area of the junction. WD equals width of the depletion layer. When reverse voltage across a Varactor diode is increased, the width WD of the depletion layer increases. Therefore, the total junction capacitance CT of the junction decreases. On the other hand, if the reverse voltage across the diode is lowered, the width WD of the depletion layer decreases. Consequently, the total junction capacitance CT increases. Note that CT can be changed simply by changing the voltage VR. For this reason, a Varactor diode is sometimes called voltage-controlled capacitor. Application of Varactor diode. The Varactor and the inductor form a parallel circuit. For normal operation, a Varactor diode is always operated under reverse bias. The resistance Rw in the circuit is the winding resistance of the inductor. This winding resistance is in series with the potentiometer R1. Thus R1 and Rw form a voltage divider that is used to determine the amount of reverse bias across the Varactor diode D1, and therefore its capacitance. By adjusting the setting of R1 we can vary the diode capacitance. This, in turn, varies the resonant frequency of the LC circuit. The resonant frequency FR of the LC circuit is given by: if the amount of Varactor reverse bias is decreased, the value of C of the Varactor increases. The increase in C will cause the resonant frequency of the circuit to decrease. Thus, a decrease in reverse bias causes a decrease in resonant frequency and vice versa.